Welcome back, grade 12s, and today we're going to be continuing with some more probability. So, listen up. Right, two events are said to be independent when the chance of one event occurring does not affect the chance of the other event occurring, or vice versa. Let's look at that again. The chance of one event does not affect the chance of the other event occurring, or vice versa. So let's have a look at some examples. If two dice, a red and a white dice, are rolled, the outcome of the red die has no effect on the outcome of the white die. In other words, rolling a 3 on the red die and rolling a 2 on the white die are independent events. They do not have an effect on each other. So the outcome of throwing a die has no effect on the tossing of a coin. In other words, the independent events there could be getting a 6 on the die and getting a heads on tossing the coin. Let's have a look at some more examples. Selecting a learner from 22 learners in Class A and selecting a learner from 35 learners in Class B. Two separate classes, selecting a learner here, selecting a learner there, two independent events. Choosing a marble from a jar and landing on heads after tossing a coin. Again, independent events. If you choose a 7 from a deck of cards, replace it, and then you choose a king as a second card. Those are two independent events. And if we roll a 1 on a 6-sided die and then roll a 4 on the second roll of the die, again they are independent events. They do not affect one another. Now, how do we find the probability when two independents occur? Well, we've got to do two things. Firstly, we're going to find the probability of each occurring separately. So the probability of the first event, probability of the second event. Then we're going to take those two probabilities and we are going to multiply them by one another. So in other words, if we now have a look in our mathematical notation, actually write a formula, then if the two events are A and B, then the probability of A and B occurring will be P of A and B is the probability of event A multiplied by the probability of event B. So this is basically a formula that you need to know, and you need to know when it is applied. In general, multiplication is represented by and. So when you see the word and, then you know it's going to be multiplication. Let's have a look at a couple of examples. First of all, we're going to find the probability of rolling a 3 on a red die and rolling a 2 on a white die. Okay, so let's have a look at the solution. So the probability of rolling a 3 on a red die. So probability of a 3 on your red die. Now, how many numbers do you have on one die? Right, there are 6. So the probability of throwing a single one is going to be 1 over 6. So now, what is the probability of throwing? Our second one was here, a 2 on the white die. So it's 2 on the white die. That is also going to give us 1 over 6. So now we're going to have the probability of the two things. Please notice carefully how everything has been set out. So we're going to have a probability of 3 on red and 2 on white. Our two independent events is going to be 1/6 multiplied by 1/6. If we multiply those two, it's going to give you 1 over 6 sixes are 36. So that is the probability of scoring a 3 on a red and a 2 on a white, 1 over 36. Right, let's have a look at another example. Felismina and Mbali get different answers for the probability of getting a 6 on the roll of a die and getting a head on tossing a coin. Felismina says that it's 8%, while Mbali says that it is 67%. So we need to know who is correct. So let's have a look. We've got two independent events here. The first one is the probability of getting a 6 on the die. Okay, so that is 1 over 6. Remember, there are 6 numbers on your die. And the second event is getting a probability of getting a heads when tossing a coin. A coin has got two sides, so what's the probability there? It is a half. So putting the two together, the probability of a 6 on your die and is your operative word there. A heads on the coin is going to be 1 over 6 multiplied by 1/2. Okay, so now if you have a look, do you remember how to, on your calculator, anytime you're stuck, use your calculator. So it's going to be 1/6 multiplied by 1/2, and that gives you 1/12. Not a difficult one, but I'll show you now why I did it on the calculator. Okay, the question says over here, Felizmina says that it is 8%, while Mbali says that it is 67%. So we need to take our 1/12 and we need to convert it into a percentage. So to get that into a percentage, we're going to multiply by 100, and that gives us 8.3%. Okay, so Felizmina was the one who said that it was 8%, so she is far closer, so Felizmina is correct. In the next lesson, we're going to have a look at another type of event.